Who said they wanted to solve a type 2 log equation? Well, I have it for you right here. Take a look. We know that it's a type 2 equation. Well, I know that you see the heading above, but if you didn't have the heading above, you would notice that you see logs on both sides of the equation. So that tells us right away we can refer to this as a type 2 equation. Now, this is not so much different than a type 1 equation, than the fact that we always try to say if we can condense our logs. So first check before you start. Look at the first side, the left side. Notice that the base for both of the natural log is e, so they're the same. Check. So if that is the case, you could condense this as a single log. So that would leave me with natural log. Since I have a minus sign, this would be the formula or the property. Remember, that is the log base b of x minus log base b of y equals log base b of x over y. This is where you're rewriting it as a fraction. So that's what we're going to do here. The argument that comes first, natural log of x. So we should have x over 4. Still has that base e. We don't have to write it if you don't want to. It's up to you. Now on the right-hand side, double check. The base for both of them, they're e, and it's the same. Yes, it is. So again, kind of look at the fact, we have a subtraction of 2 logs. So that's the same idea. We are going to rewrite this as a single log. The 3 would be in the numerator and the x plus 4 would be in the denominator. I really don't need parentheses. I'll keep that there. Now, we're going to look at this a little more closer. With a lot of these type 2s, we're going to see that if you notice that the logs on each side both have the same base, this means you can drop the logarithms and set the arguments equal. So now we can do that. So we can only do that if you have the same base on each side. So you really have to pay attention as you're going along. So what does that leave us with? X over 4 equals 3 over x plus 4. And now when we look at this type of equation, it's not as friendly as we wanted it to be. Normally we're used to seeing a lot of quadratics here, but this one's called, if you remember, this is a rational equation. And with rational equations, there's a lot of different ways to solve. I'll take it off to the side just so that you see. I like having a little bit more space than trying to squeeze everything in. So I'm going to move this way over here. And x over 4 equals 3 over x plus 4. I'll move it over just a little bit more. There we go. Okay. So with this rational equation, what I'd like to see for myself is I'll multiply both sides by the LCD. And the LCD happens to be 4 times x plus 4. So both sides, technically you're multiplying it, it's going to be over 1. And what this allows us to do, it allows us to divide out any common factors. So 4 over 4. That's going to leave us with x times x plus 4. And this on the right-hand side, the x plus 4's divide out, and so we will get 3 times 4, which is 12. And we could have actually distributed right away, x squared plus 4x equals 12. And now after doing this, we get something very familiar. There's that quadratic equation. Yay, we know how to deal with those. So we'll move the 12 over to the left-hand side. I'll have x squared plus 4x minus 12 equals 0. Let's rewrite that 12 a little nicer so we don't get confused. And we're hoping that it's going to factor nicely. So we double check. Factors of negative 12 that add up to 4. So let's see, 6 times 2 If you want to have a negative 12, we have to have one of them be negative, a positive 4. The negative should go on the 2. Again, we thank the math gods that we have a coefficient of 1. So, oh, this is so nice. Thank you, math gods. You can directly factor without doing any extra techniques. So x times x makes an x squared. We can directly use the factors that we've chosen. And now this allows us to solve. X plus 6 equals 0, or x minus 2 equals 0, which gives us x equals negative 6, or x equals positive 2. So before we circle our answers, we got to remember what we were trying to solve in the first place. Go back, go back, go back. A log equation. So don't forget, check. And what we mean by checking is rewriting our equations. So I'm just kind of, let me write it over again so we don't have to keep scrolling back and forth. Natural log of x minus natural log of 4 equals natural log of 3 minus natural log of x plus 4. And what I'm really concerned about at this stage is just double checking the arguments that have the variables. And in this case, if you're looking at your negative 6, right away, if you're trying to plug it in and you say natural log of negative 6, right away you have a negative argument. And that means we're going to throw out that negative 6. You can try it with the x plus 4 argument. It's the same thing. So that x equals negative 6 is not going to work. Therefore, our solution to this example or logarithmic equation is just a very nice positive 2. I'll write it with fancier braces. So a little bit of experience with type 2. Keep practicing. We're going to have some more challenging examples coming at you in the next examples.